All right, welcome back to geometry class. Again, I hope you did well on your homework and that seeing the solutions worked out for you as you reviewed it helped answer any questions that you might have. If it didn't, please go ahead and keep track of those that you had questions on so that when I come back, we can get those answered. But let's go ahead and look right now at lesson 102 on page 663. We talked yesterday about secants and tangents, and that their products, the external to the whole, from the external point to the far point, their products equaled each other when they had that same external point. Today we're going to be shifting gears and talking about dilations in a coordinate plane. Now a dilation, remember, changes the size but not the shape. It's going to be a similar figure when we're finished. So if you do a dilation and it looks completely different, you go from a triangle to a rectangle, a triangle to a square, then that's just a tip off that you have something wrong. But on a dilation, we're going to be using some with matrices and some with single points here. This multiplication we will do today much easier than the matrix multiplication we learned the other day. So let's look at the basic transformation mapping for a dilation. It is going to be tipped off for us by the letter D for dilation. We're going to have an O here, and that O stands for origin. These dilations we're going to be doing are going to take place from the center point of our origin here. They're going to be originating from the dilation place of our origin. The next thing, there'll be a comma after the O for origin, and this is going to be represented here by K. It's actually going to be a number, but this K here represents our dilation factor. It's a lot like a scale factor in that we're going to multiply it to our points here. We have our points XY that will be listed. Our arrows showing that there's going to be a transformation taking place here. And our new point is simply going to be X times K and Y times K. Again, much like a scale factor, we're simply going to apply that dilation factor to each point, multiplying it to each point. So let's look at an example of that. If I had a dilation with a dilation factor of 3, again, we're taking that from our origin here. We're going to simply multiply 3 to each of these, the X value and the Y value. 3 times 3 is 9. 3 times 4 is 12. There's my first point. We're actually dilating a line segment here. Here's my second point from the line segment. Again, I'm simply going to take my dilation factor and multiply it to every term here, to my X and my Y. 3 times -1 is -3. 3 times 5 is 15. It's very simple when we're using a dilation factor on a simple point here. And again, this was representing a line segment that we were dilating. And we get the point 912 and -315. If we were going to dilate something larger, such as a triangle, as we see in example 2, then a matrix is actually going to be a tad bit easier for us. Remember, this is my X value, this is my Y value, this being a single point here. This is one point of my triangle, this is another point of my triangle, this is the third point of my triangle. If we had a quadrilateral, we'd have one more. If we had a pentagon, we'd have 2 more, and so on. This time, when I'm taking my dilation, and I'm told that it's by a scale factor of 5, I am simply going to multiply this 5 outside of my matrix. Again, this is my scale factor here, multiplying to my matrix. Different from what we did the other day, much easier. I am simply going to multiply 5 by every single point, just like we did up here except this time it's organized in a matrix. So 5 times 3 is 15. 5 times 4 is 20. 5 times -2, -10. 5 times -1, -5. 5 times 4, 20. 5 times 7, 35. These are my new points. These are my new points. Remember, this is X and Y. So my new point is 15, 20, -10, -5. And my third point is 20, 35. Thankfully, they don't ask us to graph this because that gets a little large getting all the way up to 35, even 15 or 20. They don't ask us to graph it. They just ask for the new coordinates, And it's very simple to multiply a dilation factor or a scale factor here to a matrix. We're just simply multiplying it to every single term inside, every single number inside. All right, on example 3, I just want to quickly highlight a couple of things on example 3. Example 3 can look a little bit daunting, but it's not if we remember how we found an annulus. What they give us is a picture here that is going to be 5 by 3. We're dilating it by a scale factor of 2.5. They show you that with the matrix there. They take the 2.5 and they multiply it to our matrix, giving us a new matrix. And you can see that there in your book. I'm not going to take the time to work that out there. But our new dilated photo is going to be 12.5 by 7.5 inches. Now that's not what they're wanting us to find. That's fine that we found this new area of this photo, which would be 12.5 by 7.5. But they're wanting to now know if I add a 2-inch mat all the way around, a 2-inch mat, what is the area of just the mat? What is the area of just this mat all the way around? Well, we take our 12.5 by 7.5. We're adding 2 inches this way, 2 inches this way, 2 inches this way, 2 inches this way, 2 inches in every direction here, because our mat is 2 inches all the way around here. That's going to give us a new dimension, 2 inches this way, 2 inches this way, giving us 4 total inches of 16.5 inches by 2 inches this way, 2 inches this way, added to our 7.5, giving us 11.5 inches. This is the dimensions, the total dimensions with the mat. This is the dimensions of just the photo. To find it, just like we did our annulus, we're simply going to find the area of this and subtract the area here. Subtract the area here. You can see that done for you in your book, and they find that just the area of the mat there is 96 inches squared. 96 inches squared. So on example 3, don't let them finding 2 or 3 different pieces there throw you off there. You're just following your very simple same steps you've done before. And again, follow that same principle we had before with the annulus. All right, it's time for you to go ahead and get started practicing on your homework. Mrs. LaFave will be placing that on the board for you. I'll check in with you again tomorrow.